You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. To answer this question, we really need to start with identifying the correct coordinates of pi halves. Now this is simpler than the first three examples because pi halves here, I will tell you later, is a point on an axis. Let us show that using this unit circle. Okay, so this unit circle starting from here, of course we know that the entire revolution is 2 pi, so pi would be somewhere here. So positive pi, at the same time negative pi if we're going to look at the negative arcs. So simply divide this pi into 2, hence pi over 2. So you have here pi over 2. So the terminal point of pi over 2 is somewhere here. It's already on an axis. Okay, this is the arc of pi over 2. So the axis here is that. What is that value? So the coordinate now of pi over 2 is very easy to understand because we know this being the intersection of the arc and the axis, the distance of that point from the center is just equal to 1. This would mean that here, at this point, since it's vertical axis, it's y-axis, the y coordinate or y value is just equal to 1. What about x? X corresponds to our value here, so it's just 0. So the coordinate of our pi halves, or the terminal point of our pi halves, is 0 and 1. No need to argue about that. It's very easy because then again, it's on an axis. That would mean we're gonna proceed with the 6 trigonometric functions here, which I believe would be easier than the previous 3 examples because our values here are actually integers. So our cosine is the value of x. This means the cosine of pi halves is 0. The sine, okay, sine of pi halves is the y value of our terminal point. This is y. So our sine pi halves is 1. Okay? So pardon with this. Okay, that's the result now. Let's proceed to tangent of pi halves. Now, tangent pi halves is the ratio of sine pi halves and cosine pi halves. With this, simply plug in the value of sine being 1 and the value of cosine is 0. What you can see here is that the result for the tangent for pi halves does not exist. It's because we are dividing an integer by 0. So it doesn't exist here. We just simply denote it but does not exist. Others will call it infinity, but let's just call it does not exist in the realm of real numbers. Okay? Now let's proceed to our cotangent pi halves. We know that cotangent pi halves is the reciprocal of tangent, right? that's 1 over tangent of pi halves. But since tangent does not exist, will it automatically mean that our cotangent also doesn't exist? Now let's look into this. Aside from this idea that cotangent is the reciprocal of tangent, we can also call it the ratio of cosine pi halves over sine of pi halves. Okay, this is better to be understood instead of 1 over tangent, because cosine here was 0 and our sine is 1. So cotangent pi halves is 0. It exists, okay? Unlike reciprocating this, or you can also reciprocate this, okay? Simply reciprocate 1 over 0, so you have 0 over 1, which will have the same result. So even if our tangent doesn't exist, our cotangent using the cosine and sine exists in the realm of real numbers, but it's equal to 0. Let's proceed to our second. Okay, second of pi halves. Second pi halves is the reciprocal of cosine. So you have 1 over cosine of pi over 2. We know that cosine is 0, so 1 over 0. So just like our tangent, the second does not exist. Even if cosine exists as 0, our second doesn't exist. Finally, for our cosecant pi halves. This is the reciprocal of sine. So 1 over sine pi halves. Our sine is 1. So you have 1 over our sine is 1. So the cosecant of pi halves is equal to 1. As you can see, there's not a lot of scribbles here because our terminal point or the composition of our terminal point are both integers. It doesn't contain even irrational numbers. So it's very easy to understand this item. But of course, what needs to be emphasized is that when you have, when your terminal point is on an axis, even here, here, and here, there would be trigonometric functions that will not exist because there might be combinations of 0 and the quotient of denominator 0 will be resulting to a doesn't exist value. Thank you for watching.